Hey guys, welcome back to the shop. It's been about 2 months since I've had a chance to really get much done out here. We had a lot of crap going on at work. I had some small projects I had to get done and out of here. I didn't have the time to be able to try to record those and share them. They weren't anything exciting anyways. But finally back, got some time today, and in a crunch. I need to finish these steady rest jaws that we started working on. Because they're out of the spacer rings I've been making, so I got to get these jaws thrown together and get some more rings cut. I'm going to change the design a little bit. I'll eventually make them the way I originally intended, but to save some time, we're going to face mount the bearings onto these jaws instead of slotting the jaws and having the bearings fit up into them. So let me get you turned around and I'll show you what we're going to be doing, and we'll get started. Alright, so here's the new design plan we have. I'm going to drill the end of these and tap it for a 5/16 coarse thread bolt, 5/16 18. And we're going to use the shoulder of the bolt to support the bearing, because 5/16 bolt's really close to a 8mm, which is what the idea is of these little bearings. They slip up on there, but they're pretty tight tolerance. So a 5/16 bolt has roughly a dimension of 0.3125. 8mm is about 0.315, a little under 0.315. So these should work pretty well. It's not a critical fit that this bearing fit super tight on what it's being mounted to. So I think it's going to work well. I did take the only 5/16 bolts I had that weren't full thread were these 2-inch ones, so I need to cut these threads up so that it can go through the bearing and thread straight into this bar, the small washer between it. So I did do one, make sure my die was in okay shape. So here's one of the bolts. Cut threads down to it. Still has a little bit of a shoulder there, so the bearing will rest on that. And I think it'll work really well. So that's the game plan. Let me get you over. I'll get these other 2 bolts threaded down, and then we're going to take these. We're going to face the ends of them. So I can only fit 2 of them in my vise on a milling machine. So I'm going to cut the face of these down so that they're flat, and then I will measure over. Run over on the dial on my table, and we'll drill these holes to get threaded 5/16. You can see I just got the bolts set up in this vise. Got a hand die I'm going to run these down with. Normally with these hand dies you'd be feeding the stock in from this side, and what these little jaws do, when you adjust them in, they'll tighten up so you can get these nice and snug around your stock. And what that does is it makes sure that you're threading straight down that shaft. Otherwise, if you start this crooked, you can be cutting crooked and it just makes a mess. I don't need to do that because we're starting off existing threads. So I flip this die around so that I'm going to be running down this way. Put a little bit of oil in there. And this is just the cutting fluid, thread cutting oil. But we'll run this down until it just about bottoms out, and it'll give us the shoulder. Now, we don't want that shoulder to be any higher than 1/4 inch, because if it is, then the threads will be bottoming out in the jaws we're making instead of letting it tighten up. So, but there's another bolt. Run all the way down. So that'll work well. Alright, so I finished cutting the threads on these. So they have just a little bit of a shoulder at the bottom. And that rides nice and smooth for that bearing, the inner race. So I'll trim these to length later. Next, I got 2 of these jaws in the vise. Got a 3/4 inch end mill. I'm just going to use this to face off the edges of these, and then I'll switch bits and run it in so that we're a 1/4 inch in, and we can drill and tap that for 5/16. Alright, let's fire up the mill and get these cut. Now that that face is all cleaned up, I'm going to run this over. So this end mill is 3/4 of an inch. So half of that's 375. So I'm going to run this over 3/8, 375 thousandths. That's 375 thousandths. So now my cutter's centered with the end of it. So now I just got to run it over 250 thousandths, 1/4 inch. And now my cutter is centered 1/4 inch in from the end. I'm going to touch the bit off on the side so I know how far in to come to get it centered. Alright, so from this face that I just milled off, I ran the table over 375 thousandths, that's half of this end mill, this is 3/4 inch end mill. And then I ran it over another 250 thousandths, so that puts the center of my milling machine 1/4 inch in from the end, which is right where I want it. And then I touch the milling cutter off to the far side of this first jaw. So now I'll run the head up, pull the milling cutter out, run this in 375 thousandths, and that'll get the axis flush with the end. And then I just need to split the width of this jaw, and it'll get me centered on this one. And then add a full width, and it'll have me centered on this one, so we get these drills, these holes drilled out, so that we can fasten the bearings to it. Alright, sorry I didn't realize the camera shut off. So I got a 1/4 inch bit in here. That's the closest thing I had to a letter C, which is what a 5/16 thread, 5/16 first thread requires.
The letter C bit is 0.242, so I'm using a 1/4 inch, 0.250, so it's about 80 thousandths larger, but it'll still have enough bite for what we're doing. There's not going to be a lot of stress on these, so just gotta drill these through. Once this one's drilled through, I'll move it back the full width of these bars, so it puts me at the center of the next one, which is 1 inch, 120 thousandths. So that one's through. Alright. There's a little witness mark on the top here. This dial is graduated down to the thousandths. This is a 4 thread per inch screw that runs through here. So each revolution is 250 thousandths travel. So I'm going to run this back 1 inch, 120 thousandths. So there's 1, 2, 3, 4. So there's 1 inch, and then 120 thousandths right there. Anytime you're starting a hole that you don't have, I didn't put a center in this, so I'm using a 1/4 inch bit. When you go to start it, what you do is you peck at it. So you take it and just touch it off, and then pick it up, touch it off. That prevents it. If your bit isn't ground perfect, it'll wander. When you peck it, it makes it a lot more likely to go straight down where you want it to. So otherwise we'd have a crooked hole, and if I got it run halfway down there and it's crooked, there's a good chance you can snap off the bit, and it just makes a mess. So through. Alright, so now these are drilled out, so what I'm going to do is I'm going to take this bit out . And I'm going to use the milling machine to start tapping these holes, because that way it'll keep it perfectly straight up and down. Get that tightened down there first. So I won't, because of how deep these holes are, I'm not going to power tap them. If I had a spiral tap, I could probably get away with it, but being as this is a straight, this is the only 5/16 tap I have right now, so I'm not going to take a chance on breaking that off. That'd put a real quick pause in this project. Yeah. Oil in there. I'm just going to turn this head by hand.
Alright, so I tapped this one, the front one first. I'm just getting ready to start doing the second one. So I got a few threads in, tapping the hole with the milling machine. So that way, when I go to hand tap it, I know it's going to be straight on. I don't have a tap follower, and I'm not sure where my other tap handle is. I was using it on a project, and I gotta locate that. But anyways, with this, it's just a slow process back and forth. Again, this is a 4-flute straight tap. So ideally, I'd have a spiral tap, because when it's spiral tap, it helps clear the chips out as it goes. These straight taps, they're fine for thinner material, but like I'm going through 800 thousandths of material here, so these little flutes get plugged up pretty quick, and you end up having to back it out. But really don't want to snap this off, so I'll just keep massaging it back and forth, and we'll get it through. Alright, so we got all 3 of these parts drilled and tapped, and I touched both sides with a countersink to clean them up a little bit. What we've got now is I set up a temporary stop in my vise so that I can flip these around, just run them in until they hit that stop, and clamp it down. And that way, when we drill the holes for the retaining bolts, would hold the jaws in place, they'll all be in the same spot. Instead of trying to mark them and lay them out, or indicate for each one. It's just easier to do it this way. This is already still set up over center from when we drilled these holes. And I got a 13/32 bit in here, which is what you need for drilling to tap a 1/2 by 12 thread. And that's as per the Machinery's Guide Handbook. I had to look that one up because I had no clue for a 1/2 by 12. But in any case, so this is set up. Got the first one in there. We're going to go ahead and get this drilled out, and then we'll get these holes tapped for the 1/2 by 12. We can mount the bearings, and these jaws should be ready to go in the steady rest. So with all 3 have these drilled now, ready to be tapped. I'm gonna take them over to the drill press and just hit both sides of the countersink, clean up that hole, and then I'll stick them back in the milling machine. We'll put the tap in the collet, and it'll get us started square. Then we'll finish it off by hand. I'll bring you back when I get these cleaned up. Alright, so these are ready. Let's get them chucked up, and we'll start tapping these by hand. So again, I'm just using the milling machine to hold the tap. That way I know it'll start straight up and down. Just enough to get those threads going. That way when I take over tapping by hand, I know they'll be going straight up and down with a hole. Alright. Take these over to the vise and finish these off by hand. There we go, I can feel it biting in the same path. One down, two to go. Alright, well I'm going to tap this third one off camera, and we'll bring you back to trim the bearing bolts, get the bearings put on, and get these installed on the steady rest. Alright, so these parts are all ready to be assembled. We got the holes drilled and tapped for 5/16 for our bearings. These holes drilled and tapped 1/2 by 12 threads per inch for our retaining bolts. So these are the original bolts that were on the lathe on the steady rest. So these thread in there nice. What we're going to do is we still need to trim these bolts to length. I think what I'm going to do is I'm going to assemble them all onto these jaws, and then I'll just trim them off with a grinder after they're assembled. Really not a critical thing, it's not going to interfere with anything. So I'm just going to assemble. What I did decide I'm going to do, these are actually 1/4 inch washers. 1/4 inch hardware washers. If you try them on a 1/4 inch bolt, they're kind of sloppy. They actually fit a 5/16 bolt nice and snug. So what I'm going to do is I'm going to sandwich these bearings between washers, and the reason being, these washers have an OD just slightly smaller, see if you can see that, just slightly smaller than that bearing's outer race. So my thought is, potentially, it will help prevent any trash from the lathe getting into those seals and making these bearings go bad sooner than later. I mean, these bearings only cost me, I think they're maybe 50 cents a piece. They're really not much. They're not a high-end bearing. But hey, if it helps, it helps. If it doesn't, it really didn't cost me much anything anyways. So that's how I'm going to assemble these. So we'll get these put together, and then we'll trim these bolts off on the back side, and we should be ready to put these jaws on our steady rest and try it out. Alright, so we got the steady rest set up on here. Got the new jaws assembled. Ended up, I just nipped off the excess of the bolts with a porta band. I already had it out over there, so that made quick work of it. But here's the old jaws that we're replacing. I mean, I'm going to hang on to these because they'd be great for working with steel. Like I said, the real reason I'm making these with roller bearings is because of the aluminum tubing that I've been needing to machine. So they fit in there nice, just how the old ones did. Get our retaining bolt in. Done. Two. Grab the other bolt. Three. And there we go. All three are installed and they look good. Alright. Well, I'm going to call that a wrap. I think these new jaws are done for now. The one thing I noticed, I didn't match these exactly, as on the bottom end I didn't do a radius. And this radius actually would allow them to fit up closer on the inside here, because these were a milled slot. So obviously the end of it's going to be round from the milling cutter. So at some point I might mill that radius. I have a rotary table I can do it on. But I've got that disassembled to clean up and get freed up. It was seized up. It came with a milling machine when I got it. I just haven't gotten around to finishing that project. But in the future I might pull these off and mill the radius on the end of these. But yeah, as for now, this is going to work great. It opens up plenty enough for me to fit that aluminum pipe into. And we're going to call this a wrap. So thanks for watching. Hope you guys enjoyed it. Any comments, feel free to leave them, please. Tips, questions. Let me know what you think. If you liked it, please give me a thumbs up and subscribe, and I'm going to try to keep putting a few more of these out. Thank you much. Have a great night.